Alright, so we're going to start with number 5 here. Box weighing this, rests on a table, a rope tied to the box runs vertically over fully. Weight is on there and inserts on the box, the weight hangs does each of this falling. Okay. So, rather than me trying to draw that, capture it. Right. So, we have 5. We would have the, I'm going to call that FGH for the weight of the hanging mass. We have FG, they call it a box or a pack? A box. So FGB for the box. There would be a normal force here and a tension. And if there's a tension up there, there has to be a tension down here. And same here, a tension and tension. Yep, that would be what I would grade as full credit for. Oh, probably it'd be a good idea to have this. But that would be a full credit diagram on Monday's in-class problem. Alright? So, you need to have all of those parts. This is the problem. Then we go down and do our free body. We need to do 2 free bodies. One of the box and one of the hanging mass, I would say. So if I do, this will be the box over here, and this will be the hanging mass here. And the hanging mass, really very straightforward. I'm going to have the weight of the hanging mass and the tension up. Here we'll have the weight of the box, the tension up, and the normal force up. Yep. So, in all the cases, the weight of the hanging is going to equal the tension, right? Hopefully you see that. If not, I can elaborate. And here, we have force normal plus the tension minus the weight equals m times 0. They want us to determine the force table exerts on the box, which would be the normal force. So, rearranging this to get normal force, I would have the normal force would equal the weight minus the force due to tension. And so now the weight, they tell me, the weight of my box is 70 newtons. They tell me the weight hanging in each of these cases, and that we saw up top here is the same as the tension. So I basically have the two numbers, I subtract them, and I get the normal force. So that's that one. Alright, so looking at number 2. So, two, if you to picture it, you can picture number 3 here. That's the same setup. So, using my my drawing ability here, this is number 2. We have the man in his chair. The rope goes up, goes around the pulley, and then it is really attached, connected to the man again. So, you would have his weight down. You would have a force of tension up here. You have a force of tension down here. You have a force of tension down here. And you'd have a force of tension up here. And then I'm guessing he's going to accelerate upwards. If I'm wrong in that guess, either A will come out to be 0, or if it's downwards acceleration, then A will come out to be negative answer, and I know I just picked the wrong direction. Alright? So that would be your force diagram. And I only really need to do the free body of the man sitting in the chair. So if I do the free body of the man in the chair, I get his weight down, F sub t up twice, and that acceleration up. So, using our one equation, I get F2ft minus Fg equals m times the positive A. Right? Now I look and see, what do they tell me? Oops. They tell me the tension in the rope, because if he's pulling on it with 421 newtons, it's 421 newtons everywhere. They tell me the inertia, or the mass of the man in the chair, and they want to know with what acceleration does he move up. So, alright, so they tell me the tension, they tell me that they want to know the acceleration. So I'm going to 2ft minus mg equals ma. I divide both sides by m. I can get a by itself. Now I can substitute in what I know. 2 times 421 newtons minus 72 kilograms times 9.80 newtons per kilogram all over 72 kilograms will equal A. And hopefully I get a positive value so it's moving upwards. Yeah? I read my problem, and it says that he pulls on the rope with 421 newtons, which that would create a force in the rope of 421 newtons, which would be the same throughout the rope. Oh, yeah, see, and now the next one, exact same setup, but they give you different information, right? So they see if, so I'm seeing if you can do the same problem, but with 2 different approaches. Any questions on that one? All right, so we're going to move on to number 1. The minimum force F plus the piano, all the other tensions they want. Okay. So, number 1. I realized right away in drawing that this force here, which they labeled F, that's going to be the same as FT1 and FT2. So I'm just going to call that FT. you realize that's the same as F. I would have an FT up here, an FT down here, an FT up here, an FT down here. On this top pulley, I'd have FT3 up. If I was doing it for the ceiling also, I would again have another force down, but I'm not worried about that. I'd have two forces in here called FT4, and I would have the weight of the piano down here. And one thing you should realize, and you might even note it, is that FT2 equals FT1, which also equals FT, which also equals F. So all of those, because our pulleys are light and frictionless, the tension throughout the whole cord is the same. All right? So all of those are going to be equal. I could go through and label all these FTs and FT whatever, but getting the main ideas in there. So now I want to find out those tensions, but I also want to find out FT3 and FT4. So I need to do a free body of the piano. It'd probably be a good idea, yes, then to do also one of the lower pulley and one of the upper pulley. So I would expect in your how for this one to have 3 different free bodies. All right, so I'll do them here, and we'll do the piano over here. We'll do the lower pulley, and then we'll do the upper pulley here. So for the piano, it had its weight down. None of these have acceleration. And let's see, that was FT4 up. For the lower pulley, that one there, we have FT4 down, FT up, and FT up. And I'm just generically using FT because it's less writing than writing FT1 and FT2. And I know all those are equal, so I could also just use F there. Then if I look at the top pulley, I've got FT3 up. I've got 3 instances of FT down. Alright, so those would be the 3 free bodies for this problem. And then I think I'll start and I'll work left to right, worry about where the chips fall. So some of the forces is MA, and we'd have FT4 minus FG equals M times 0. We'd have FT4 equals MG. And then if I look at that center one, of course, I'd set it up the same way. But what you should notice is that you'll get to the point of 2 FT equals FT4. And over here, you should realize you get to the point FT3 equals 3 FT. And that should give you enough information to be able to solve it. Yeah. Hopefully you're starting to see those relationships directly from the free bodies. Not always having to go through every mathematical step, but if you're not, stick with the steps. So, how would I write that in terms of mg? Well, I'd look at what coefficient would be in front of it, and it would be the number 1.